Good morning, ma'am.
So from next week, you all are coming for your offline classes. Did you get the notice?
No, no, we haven't got any notice from college. We have only seen it in news.
Okay, that only from, I mean, even news भी सुनी कि मैं coach.
Again, ma'am.
So you all are coming. हाँ, 7 sem का तो
Yes,
बस
ma'am.
चालू थी, तो obviously हम को भी चालू है. So all have taken your vaccine. Second dose completed.
No, ma'am. Second dose everyone has not taken.
Okay. But first dose हमसे नहीं था था.
Yes, ma'am, almost.
हाँ. For mental satisfaction, we should take those, but then I don't know for how or नहीं. But at least you all should take. Okay then. So offline हेले A and B अलग अलग है कि then maybe जब student अधिका है कि कौन अपने A1 A2 B1 B2 कौन करेंगे like the last semester. So we'll just see कौन which. So last class what I taught, any idea? मैं भूली ही कौन पढ़ी थी because both gap in each. Divyasha, can you say last class कौन पढ़ रही थी ना? You were there ना? Divyasha Das. Divyasha, are you there? Okay. Anjali Nayak.
Yes, ma'am.
हाँ लास्ट क्लास कौन पढ़ा इतना?
मैंने वन पेज फुल वेव कंट्रोल रेक्टिफायर विस्तार पढ़ती हूँ.
You are not audible.
मैम वन पेज फुल वेव कंट्रोल रेक्टिफायर विषय पढ़ी लास्ट क्लास.
With RL load?
खाली आर लोडिंग पढ़ती हूँ.
अच्छा ठीक है. Okay. So we can do one thing. So all of you please draw a single let me share the screen. Okay, Divyasha Das, I don't know whether she's there or not. Please inform her that tomorrow she will be presenting on single phase semi converter. Okay, single phase semi converter with RL and RLE load.
Okay, ma'am.
अब Google लगेगा ना one single phase semi converter. Okay. So all of you today what we'll do? Today we'll derive. Hello. At least good derivation कर ले, you will be confident enough. ठीक है. So today we'll discuss about. But मते लाଗୁଛି ମୁଁ RL load discuss କରିଛି. But I think so. What about others? Rahul.
Madam, R load data is
RL करছি ना?
Yes, ma'am. RLE.
R और RLE को
Yes, ma'am.
लास्ट को କହିଥିଲେ କି RLE লোডটা ବୁଝି ଗেছে ଆମେ
हाँ ସେଇଟା
जो
ହିଁ ମତେ
BT କରିଥିଲା
okay ଠିକ ଅଛି okay I'm drawing the converter ठीक है so all of you draw the output voltage and derive the formula for average output average voltage and RMS average voltage hello then I'll ask anyone to show his or her copy so I'll be drawing full wave So this is my Vs that is equal to Vm sin omega t. Supposing this one to be T1, T3, T2 and T4. This one is R and L. So all of you please draw जब भी करिए फिर भी all of you draw V0 in your copy and derive the expression for average output voltage and VRMS. The question is, I have drawn, this is which type of converter? Sorry, control हवा होता है ना? Single phase, fully controlled converter with RL load. Okay. The question is to draw this V0 output waveform and also derive करिबो है ना? VDC and VRMS or V average and VRMS voltage. Expression करे सब derive करो. Assuming the output current to be a continuous one when it is operating in continuous mode.
मैम अल्फा वैल्यू किछि
नहीं alpha just alpha general because derive करिबा ना तो simple
मैम मोर
alpha.
आउ गोटे डाउट थिला
हाँ.
जति हम अल्फा दोचे आउ आरएल लोड अछि
हाँ.
ताले हमें बीटाटा केमिति जानिबा कोठी आसीबो एक्सटेंशन एंगलटा
that we need to माने तारे गोटे इक्वेशन बाहर करके then बीटा हमको कैलकुलेट କରିବାକୁ पड़िବ. I0 general expression that I'll tell you today. ठीक है?
यस मैम
Good question. Is the waveform correct? V0.
यस मैम
Okay. What about others? But A portion, those 0 to alpha, they should be in the output or not?
मैम नेगेटिव आउटपुट रहया कथा
हाँ, good. है ना? तो A तभी भूलिबनी whenever you will draw this. So now derive the expression for V average and V RMS. जेहेतु continuous mode अच्छी, so no beta is there. अच्छा, so we can say that ये जो like from alpha to pi plus alpha, which pair of peristors are operating from alpha to pi plus alpha? Positive cycle.
T1, T4.
T1 and T4. Then जेतले negative है योची, even when it is negative because of the discharging of L, the T4 and T1 flows. Okay. So actually we can say in this RL converter, even suppose no I0, if I'm drawing the I0 current, this is omega t with respect to omega t. So I0 current यदि मैं draw करबी, so like suppose when the positive cycle is here, it is flowing through T1, then RL, then T4 and then negative है तो वो I0 current है downward, I mean you can say plus and minus जो भी multimeter को देखिए and because of the presence of your L slowly rise करेला ना then negative cycle रे कौन होची the negative cycle रे how the current is flowing I0 in the negative cycle L P4 like this inti flow hochi negative cycle re the slides have been shared now negative cycle inti flow karuchi
Ma'am, L, T4, T1 R.
हाँ, good. So, but it is falling. Thank you. ना discharging होची है ना. Okay. So you can say here T1 and T2. T1 and T4 is conducting. Here also T1 and T4 is conducting. ठीक है. But we know that power is nothing but V into I. If I talk about instantaneous power, V into I. Or I can say if I will draw a power curve, है ना voltage waveform और current waveform रू यदि मैं गोटे power waveform draw करबी, that means I have to multiply these values. माने a curve under a जहाँ value अच्छी, a curve under a जहाँ value अच्छी into this curve, isn't it? Alpha to pi plus alpha to pi range ray, if I multiply V0 into I0, what will be my power? Alpha to pi, this power will be positive because V0 तो positive value सबू रहेला, even I0 भी positive value रहेला, so positive into positive is a positive. बुझिला?
Yes, ma'am.
हाँ. So P is positive means we say that the power is supplied from source to load. Source to load को power supply करा होला. ठीक है? And if I represent this whenever when I suppose તમે chopper electrical પઢିବ તો you will find out that ଆମେ voltage V0 and I0 को generally in quadrant ରେ represent କରୁଛେ ହେଲା so suppose this is my I0 and this is my V0 तो এটা ମୋର first quadrant ରେ হবো V0 and I0 0 to মানে pi sorry alpha to pi I can represent by this first quadrant because V0 is positive and also I0 is positive. Getting my point? If I will represent this voltage and current waveform as quadrant, so it a co-quadrant ଆସିବ V0 positive, that means ସବୁ positive value, and I0 ର ସବୁ positive value. So this we say that the converter is operating in the first quadrant. जोटे मोर V0 positive अच्छी and I0 positive अच्छी and also power is positive. Okay. ठीक है. Now this alpha to pi plus alpha. Sorry, pi to pi plus alpha. Second, suppose pi to pi plus alpha. So pi to pi plus alpha, the output waveform V0 is negative, but I0 is positive. I0 decrease होउछि किंतु तार value positive, but एठी V0 एटा negative part रे आसला हैला तो if I represent this in quadrant, this is my minus V0, एटा हला मोर कोन minus I0. But if I have to represent this V0 and I0 as quadrant, how will I represent? V0 तो मोर positive रहला, sorry negative हैला, तो I have to go to this quadrant, এটা co-quadrant fourth. But I0 is positive. So we can say that from alpha to pi, this converter operates in the first quadrant. हैला माने first quadrant माने कोन मोर output voltage and output current हैला positive and also power is positive. The power positive means it implies that the power is delivered or there is a transfer of power from source to load. But when we go from pi to pi plus alpha, we can see that the output voltage is negative and the output current is positive. So it comes to the fourth quadrant. So here what happens? Power ta kaun hoga? Negative into positive value will be a negative value. So more power ta negative hella means it implies that what it signifies that power is transferred from load to source. जोटा कि तमरा power negative को case रे हुए only in presence of your capacitor and inductor only. जोटे charging discharging concept आसुची. In that case only we have negative power. So negative ये जो plus minus को it is nothing but a notation of the power. हैला. The power positive means the power is transferred from source to load. Power negative means the power is transferred from load to source. So we can see here now pi to pi plus alpha L rho. I mean the discharging take place from L T4, then the supply, then T1 and then Rn. Okay. So this I mean ये जो alpha to pi plus alpha. So what we माने you can say that because of the presence of L and C, these are what type of elements? Energy storing element, na? L and C, they are energy storing elements.
Yes, ma'am.
So because of the presence of L and C only, we can supply the power from load to source. Okay? But this concept does not exist when we have pure R. Pure R we don't have any negative power. That means there is no supply of power from load to source. Ulta power dissipates because of your R. Understood the concept?
मैम आउ थे
Yes, ma'am.
लास्ट
ओके तो सिमिलरली एटा कंटिन्यू करिवो देयर इज इंक्रीजिंग डिक्रीजिंग एंड हियर इट विल बी 0 to alpha कोन होबो whether it will increase or decrease I0 this part ना decrease करिवो ओके ठीक है now from this I0 if I have to draw the current through IT and I4 T1 and T4 sorry the current flowing through T1 and T4 how can I draw किमती ड्रॉ करिवो current केतले फ्लो करे only when it is conducting ना तो T1 and T4 को region रे conduct करची को angle T1 and T4 alpha to pi plus alpha तो alpha to pi plus alpha I0 waveform जहाँ that is the same waveform for T1 and T4 because T1 and T4 they are conducting from alpha to pi plus alpha only and I0 is the same current I0 load current that is flowing through R and L and it is the same current that is flowing through T1 and T4 so it will follow this path then pi plus alpha through 2 pi plus alpha is there any conduction in T1 and T4 alpha to pi plus alpha T1 and T4 conduct kala then alpha plus pi pore ko thyristor conduct karuchi T2 and T4
Yes, ma'am.
T3 and T
ha T2 and T3 good so T2 and T3 co region re conduct kala co angle ru this much pi plus alpha to 2 pi plus alpha okay
yes ma'am
but there is no conduction in this T1 and T4
yes ma'am
okay so I'm now talking about when the angle is pi plus alpha to 2 pi plus alpha okay so in this area or you can say in this duration T2 and T3 only these thyristors conduct okay what about T1 and T4 they don't conduct so no conduction means will there be any flow of current यदि T1 and T4 conduct करूनी तो will there be any flow of current ए रेंज रे देखो नो कंडक्शन होनी फ्लो ऑफ करेंट नहीं किंतु खाली वोल्टेज ड्रॉप होबो हला माने सॉरी आई मीन वोल्टेज विल अक्रॉस अपीयर अक्रॉस द T1 and T4 बिकॉज़ इट एक्ट्स एज एन ओपन सर्किट हला तो ड्यूरिंग दिस रेंज दैट इज दिस रेंज इज pi plus alpha to 2 pi plus alpha okay so during this range there is no conduction through T1 and T4 so the current will be 0 this is current will be 0 again after 2 pi plus alpha it is conducting so it will follow the I0 value so 0 to alpha it is not conducting so it is 0 bujhila my point
Yes.
so T1 and T4 current waveform will exist ko jagah re it will exist between the where T1 and T4 are conducting so T1 and T4 is conducting from like alpha to pi plus alpha then 2 pi plus alpha to up to 3 pi plus alpha whatever jabi hela तो जो टी कंडक्ट कोची सेठी it will follow same as your I0 waveform तो I0 waveform और जेमती अछि because of the presence of inductor T1 and T4 भी same रहबो and बाकी जगह रे it is not conducting so it will be 0 ठीक है now if I want to draw the current waveform for T2 and T3 T2 and T3 केमती हबो we have to use the same concept as we have used for T1 and T4. So T2 and T3 conduct करूची pi plus alpha to 2 pi plus alpha. So एटी मोर जहाँ I0 waveform, the same waveform will be here, and जो T conduct करनी it will be 0. So alpha to pi plus alpha, T1 T4 conduct करची, but T2 T3 करनी, so it is 0. And again after 2 pi plus alpha it is not conducting. Now 0 to alpha it is conducting, so it will be decreasing. Got it? So you can say for cross checking, तमे कौन कही परिबो? The current through T1 and T4 plus the current through T2 and T3 will give me the waveform of this I0. बुझिला? What I want to say? एट एटा waveform को जदि मो add करी देबी, I'll get the I0 waveform. Clear? Clear or not?
Yes, ma'am.
Yes, ma'am.
मैम मोर गोटे डाउट थिला
हाँ कुह.
मैम जो 0 ରୁ अल्फा भितर तो कंडक्ट करबा कथा नु आपण जो नेगेटिव पार्टटा
अरे देखो आमे जतले एसी सप्लाई तो दोचे, एसी सप्लाई जतले हम दोचे हला 0 टू अल्फा माने आमे थोड़ा जानचे कि तार 0 पॉइंट कोठी अछि. दे 0 पॉइंट मो कोन गोटे पॉइंट मो हिसाब मो रेफरेंस नोची ना. एक्चुअली वी आर सेइंग ओके ठीक अछि तमरो स्टार्टिंग पॉइंट हैला अल्फा. ठीक है तमे एटा भाबुछ त मो 0 रु देली बट अल्फा रे मोर ऑपरेट करिला क्या तो.
यस मैम.
ठीक अछि. तो बट दिस एसी माने कोन इट इज रिपीटिव इन नेचर ना. रिपीटिव इन नेचर माने कोन तरह साइकिल हिसाब रे मोर बीट माने देयर आर टू पेयर्स ऑफ थायरिस्टर T1 T4 गोटे पेयर, T2 T3 गोटे पेयर हैला. तो ए डेटा पेयर गोटे साइकिल जदी T1 T4 कला आउट साइकिल T2 T3. तो ए जो 0 टू अल्फा ठीक है दिस वी आर सेइंग दैट इट इज रिपीटिंग माने या पर जोटा अछि अल्फा हां माने वी आर मेकिंग इट अ कंटीन्यूअस वेवफॉर्म.
Negative portion signifies the reverse blocking mode.
हां तो एटी कोथ पेयर ऑफ थायरिस्टर कंडक्ट करिवो. See, I am drawing this part in order to represent that it is a continuous process.
बट मैम कंटीन्यूअस हेले भी जदि हमें गोटे फायरिंग एंगल देई ने सते जाय कोन गोटे नेगेटिव पार्ट आसी पारिबो.
सेटा ही ना देखो ए पार्ट रे मोर T1 T4 कंडक्ट करूनी. This T2 T3 is conducting.
मैम बिकॉज़ टाइम कोचिन हमर पी सिम रे भी हमें करितलो लेकिन जो पार्ट रे हमें फायरिंग एंगल देलु ता परे ही नेगेटिव आस्तला बट ता पूर्वरु से पार्ट ता पूरा जीरो रहतला.
तो सेटा अरे देखो सेटा तमे जेतरे सिमुलेट करूछ हला तो यू आर डिफाइनिंग अ जीरो.
इनिशियल कंडीशन स्टडी जीरो एरिया में नो इनिशियल कंडीशन है थियोरेटिकली
हां एटा मो थियोरेटिकली बुझोची माने आई एम सेइंग इट इज रिपीटिंग हला. तो मे बी मो बाय 0 एटा हे पारे. तो एटा जदी मो बाय 0 बुझी
आपण को गोटे पार्ट ने की बुझोछ.
हां से ही. तो तमे जेतरे सिमुलेट करूछ तो तमे डिफाइन कर देले एटा मोर 0 हला. किंतु मो एटा डिफाइन करने एटा मो थियोरेटिकल कोच एटा कंटीन्यूअस प्रोसेस गोइंग ऑन.
यस मैम.
ओके बट या कि ए नेगेटिव पार्ट रे मोर T2 and T3 conduct करूची.
यस मैम.
है ना? गुड. ठीक है. Now, if I have to draw the voltage waveform across T1 and T4, तो एक वोल्टेज वेवफॉर्म टा उल्टा हवा ना. जो केस रे मोर कंडक्ट करूची T1 and T4 से केस रे मोर voltage will be 0. It will act like a short circuit. So alpha to pi plus alpha it is 0. Then baki time re सोर्स वोल्टेज टा ता अक्रॉस से आसुच माने बिकॉज इट इज ब्लॉकिंग माने नॉट कंडक्टिंग तो नॉट कंडक्टिंग जो जो रीजन ए रीजन रे तो दैट सोर्स वोल्टेज विल कम अक्रॉस दैट पॉइंट पुनी कंडक्ट करला पुनी जीरो तापर पुनी सोर्स वोल्टेज ठीक है सिमिलरली VT2 एंड VT3 जो रीजन रे कंडक्ट करছে সেটা जीरो बाकी रीजन रे मोर सोर्स वोल्टेज टा आसीबो सो सोर्स वोल्टेज माने कोन नॉट द कंप्लीट पार्ट okay now if we have to derive the
मैम
हाँ
मैम 0 रु अल्फा भितर VT1 VT4 कोन हबो
अल्फा
मैम 0 रु अल्फा भितर VT1 और VT4 टा देखैलेनी कोन हबो
VT1 and VT4 नेगेटिव आसीबो माने जो नेगेटिव वोल्टेज अछि दैट विल अपीयर
ओके मैम
हैला
यस मैम
okay now how to derive the average voltage or the DC voltage of output voltage or the DC value of output voltage so कौन equation लिखे बाद if I look at the waveform this one हाँ केमती लिखा इक्वेशन
मैम एवरेज आउटपुट 1 by pi dm sin omega t d omega t from alpha to pi plus alpha.
Good. So we will take the time period 1 by t. तो इथे हमें time period pi में योचू because it is continuous. So 1 by pi, then the range will be like alpha to alpha plus pi or pi plus alpha. Then it is following the Vs waveform, so it will be like Vm sin omega t dt. ठीक है?
मैम d omega t हवा का
हाँ d omega t. Okay. In some books you can also find like this 2 divided by 2 pi. So 2 divided by 2 pi कौन पे करा होगा? Any guess?
मैम गोटे 2 pi
Good.
साइकिल भीतर दीटा पॉजिटिव और
Good, good. That means 2 pi is my total time period. So 2 pi भितरे I am getting 2 cycles. So 2 divided by 2 pi. either you can eta bhi thik achi eta bhi thik achi jota तुमको ठीक लगे ठीक है so integrate for all of you please integrate this and tell me the value माने expression
integration dm by pi cos alpha.
okay all of you getting the same value प्रतिभा
Yes, ma'am.
इंटीग्रेशन करछा
No, ma'am.
कौन पूछा
ना मैम करेंगे
और सिंपल अच्छी ना इंटीग्रेशन ऑफ साइन ओमेगा कौन इंटीग्रेशन ऑफ साइन ओमेगा इज इक्वल टू माइनस cos ओमेगा t देन खाली सब्स्टिट्यूट करिवो वैल्यूज
Yes, ma'am.
लिखसा नायक तो सी माने मते लागछि बोधे ऑफलाइन एग्जाम हबो जदी ऑफलाइन एग्जाम हला तो क्वेश्चन में बी theoretical question, like suppose draw the circuit diagram of a single phase full wave control rectifier with RL load. Maybe se likhi pare continuous or discontinuous. So depending upon the marks, jodi 5 marks thibo to ko bhi mode assume kar dabo continuous ki discontinuous and do it, or 10 marks se thile both the waveform draw karibo hala. So the question may be to draw the converter and it's jaha bhi voltage waveform ke output current waveform se jaha specify karthibo seita draw karibo. And the question may be also to derive the expression for your average output voltage and RMS output voltage. Hala. Either in the theoretical question पे ऐसी परे. So for that यदि 10 marks हला तो obviously तुमको integrate करें पड़ेगा ना, direct formula तो तुम लिखी पड़ेगा नहीं. The expression with the integration and the formula. ठीक है. Or theoretical, I mean problematic question has to go. The values like alpha and V, माने supply voltage, RMS value, R load, ये तो values दे दिया, and then problematic. You have to solve the problem. ठीक है, तो सेठी भाई इंटीग्रेशन बोली का तो मैं नेग्लेक्ट करा ना. You have to integrate. So I hope all of you got this answer. Vm by pi, integration of sin omega t is minus cos omega t, and the range is alpha to pi plus alpha. Tapre kendi kariba? After this, mone achi ki nahi
We put the
integration?
values.
Good. So it will be minus cos pi plus alpha, then minus minus plus cos alpha. Tapre then
minus cos pi plus alpha टा है जीवो cos alpha 2 cos alpha मिल जीवो से.
good. So this one is my cos alpha. So it will be 2 Vm by pi. Okay. So tell me what will be the maximum value of output voltage from this expression?
2 Vm by pi.
Good. Vm by pi. So alpha value कितने? Maximum voltage by 2 Vm by pi.
0.
Good. Because the maximum value, I mean, कितने जान लेते maximum voltage?
For cos alpha equals to 1.
Because the maximum value of cos alpha is 1. Hala. So 1 substitute for the so it is 2 Vm by pi. So you can say this maximum voltage will take place when alpha is equal to 0. Obviously, from the waveform also we can say alpha equal to 0 हेले कौन पूरा total जहाँ supply voltage थिला सेटा मोर output voltage हिसाब से आसे. ठीक है? Then VRMS expression बाहर करा. The same thing खाली square and root over will be there. So 1 by pi integration alpha to pi plus alpha, then Vm square sin square omega t d omega t, then root over, or I will write it as to the power 1 by 2. All of you integrate. Today specifically I am dedicating the time for this integration actually.
Ma'am, Vm by root 2 asche.
Vm by root 2 asuchi very good. But the beach wala step sabu kara. Integration. So sin square omega t you can convert it as
1 minus cos 2 omega t by t.
Good. So all of you integrate. I'm giving 2 minutes. 2 minutes to the age, I think. 2 minutes time. যদি ইন্টিগ্রেশন মনে নাই গুগল এন্ড ফাইন্ড 1 minus cos omega t তারও তুমি কোন হবো and all that.
Yes, ma'am, actually.
Rahul is done. Good. Devi Prasad. Huh? Satya Prakash is done. Devi Prasad?
Yes, ma'am, done.
Devi Prasad, are you there or not?
Yes, ma'am.
କରୁଛ ନା ହେଇଗଲା? ଆଚ୍ଛା ଆଚ୍ଛା କର। Okay, Rahul, you do one thing. See the photo, take it, like share in the group. माने
Yes.
अनऑफिशियल माने लाइक पी ग्रुप जेटा अच्छे से शेयर कर दियो। Swagat Vishwal, are you doing? Swagat, are you there? Swagat Vishwal. Achha na, you were feeling hungry when? I think most of the students are feeling hungry and they are not there, huh? Both the Siddharth. Good, nice, very good. Okay, all of you, आज हमने जहाँ भी करी थी, okay, that you might have written in one page because मो बहुत time देली for the waveform and all that. जहाँ मैंने जहाँ जेमिति भी करी थी, just take a screenshot of that and in the Google Classroom, I'll create an assignment. है सेटा post करिबो within 4:30. है क्लियर? आज क्लास रे जहाँ जे लिखिछ जेतिक लिखिछ अधा हाफ इंटीग्रेशन करिछ करिनो इट्स ओके बट जेतिक भी लिखिछ तार स्क्रीनशॉट नबो एंड आई विल क्रिएट एन असाइनमेंट इन अ गूगल क्लासरूम ताको पोस्ट करबो विद इन 4:30 ठीक है so it's a surprise for you all okay so shall we move ए राहुल तुमको एबी पोस्ट करे को कहली ना हबनी टाइम लगे
हमें जुइस
then I can do one thing. One minus cos omega 2 by 2, then omega t. So all of you can see, those who are stuck somewhere or Jahabi. ठीक है तो okay where I was. So this Vm by 2, so Vm is what? The maximum value of the supply voltage. A Vm ta code hasuchi. The Vs is equal to Vm by so sin omega Vm sin omega t. See two more hasuchi na. This Vm is the maximum value of the supply voltage. So Vm by root 2, I can also say that is nothing but Vs or Vs is what? The RMS value of the supply voltage जोटा कि तुम्हारा क्वेश्चन रे देता है. Got it? बुझिला मु कौन पूछी? This Vm by root 2 is nothing but the RMS value of the supply voltage which is directly given in the question. Okay. So we can say that in case of a single phase full wave rectifier with RL load, the RMS value is dependent on कहाँ पे depend करची? The RMS value. I'm audible or no?
maximum value of
You can say it is
voltage.
dependent on the supply voltage. Yeah. Only supply voltage. आउ किसी माने alpha or something does not. Okay. Now coming to the current expression I0. So whenever there is an L hela mane like we have to write like this na. केवल जब हमें लिखिवा it will be like a differential equation will be there. Ri plus Ji by dt equal to Vs or equal to 0 depending upon तमें को case consider करूँगा हला. So di by dt, there will be one differential term. So differential term के लिए मने we can say that this I0 will have two parts, the steady part and the transient part. Okay. So यार गुटे fixed, I mean there is a general equation for this I0 and that I0 is equal to Vm by Z. So Z stands for the impedance. So impedance of this RL load कौन? R square plus X square root over. So Vm by Z sin omega t minus theta minus sin alpha minus theta e to the power minus omega t minus alpha I think it has to be by omega theta. Just a minute. So it's from the Daniel handbook I have got the expression. by omega t tau. Actually, that means you can derive from this जिनके हमें R load पे derive करते हैं the differential equation and then you can derive like that. और इस standard general notation को भी तुम्हें मने रखी करते हो. It will be good if you remember this so that you can easily find out the average and RMS value. Okay. और by R को भी तुम find out कर पारिबो. So this tau is nothing but the time constant because e to the power t tau. ठीक है. So tau is the time constant, that is L by R. Then this Z is the impedance, that is R squared plus omega L whole square root over omega t theta. Okay, theta is the phase angle between the voltage V0 and I0, the phase angle. So this theta will be tan inverse of omega L by R and alpha firing angle. Okay, so just remember this expression and we'll try to solve some problem related to this single phase converter. Okay, so all of you write this expression or take the screenshot, Jahabi. If you are done, then we'll proceed to other. So tomorrow what you do to this same converter, है ना? In the same converter, you add a freewheeling diode and draw V0. ठीक है? Freewheeling diode add करके draw the V0. बुझिला काली कौन पढ़िबो. Okay.
Yes, ma'am.
So ठीक है. अभिजीत प्रधान, are you there? अभिजीत प्रधान.
Yes, ma'am.
अभिलाष.
Yes, ma'am.
अभिषेक सामल.
Yes, ma'am.
अध्याशा.
Yes, ma'am.
अंजलि प्रियदर्शनी.
Yes, ma'am.
अंकित.